Good evening, students. So I am going to discuss about energy propagation of the wave. So here we have already discussed about the nature of the wave, equation of the wave in the previous class. So today I am going to discuss how energy is being propagated from the wave. As you know that the wave is like this. So when wave goes from one place to another, so there will be a direction of energy propagation. So these are the thing where we will able to understand how energy gets propagated. So let us consider this electric field energy. This is magnetic field energy. So it will propagate in the forward direction. So we will discuss this thing in a more broadly. So on the basis of energy propagation, uh, on the basis of the energy propagation, progressive way, we can divide it in a progressive way. So first of all, we will learn about the progressive wave. These waves advances in a medium with the definite velocity, and this wave propagates in energy in the medium. For example, sound wave, light wave, all this type of wave will continuously move like this, like this, like this, like this. It may move like this: compression, rarefaction, compression, rarefaction. So these are called progressive wave. So it will be move continuously without any hindrance or without stopping anywhere. If we go for a progressive wave, so equation, so we know that earlier we have know that equation is equal to y is equal to a sine omega t plus phi. But now it, since it is a progressive wave, so we have to add or wave. It is not a simply SHM, it is also wave, so we have to add minus kx. Why? Because in SHM there is a to and fro repeated motions are there around a certain point, but here we don't need this. Why? Because not only as the movement of the wave is not only in the form of SHM, but also there is a propagation of a wave. It means that the propagation of the energy will happen, and if propagation of wave will happen, so we need to add more variable which is called x direction variable. Earlier we know that this is the thing, this is the phase difference. So what happened, it will form a like SHM like this, to up and down, up and down, up and down, like this. But as we know that the wave will move in a forward direction, so we have to add some variable in such a way that there is a constant k and there is a variable x. Okay, so I hope you have understood why to add minus kx. So whenever you want to write a equation of a wave, so you know that earlier the wave SHM equation is your a sine omega t plus phi, where phi is the phase difference. Now for a progressive wave, we need to add like this: y is equal to a sine omega t minus kx plus phi, where k is the wave number. We have already discussed this wave number. Okay, so if let us discuss this thing. If the disturbance is same, then what will happen? If the disturbance is same, then what will happen? For example, let us consider there is a point at x naught. There is a point x is equal to x naught at a time t is equal to t naught, and there is another point we have taken where time is equal to t naught plus t, where an x is equal to x naught plus x. Okay, now if we consider that both have same disturbance, both will behave as the same way. So what we can write? So if the disturbance is same, so we can write omega t naught minus k x naught plus phi, and this is equal to omega. In place of t naught, we can write here time will become t naught plus t, and x will become x plus x naught. So when we do this, so we will get like this: 0 is equal to omega t minus kx. Okay, I hope you have understood why. If you calculate this, you will get this same thing. Okay, if you calculate this, we will get the same thing. So let us move forward. So when we got 0 is equal to my omega t minus k into what? X. So you know that if wave is moving with the velocity v, if wave is moving with the velocity v, so velocity v is equal to distance traveled by time taken. So in place of a velocity, x, we can write x is equal to velocity into time t. So I have written like this. So finally, we will get omega t is equal to k into v into t, where v is the velocity of the wave. You should remember this. It is not a velocity of the particle. Let us consider the particle is moving up and down like this, top and bottom. So the velocity of the particle we are not considering. We are considering the movement of the wave in this direction. So this is finally the velocity of the wave. So velocity of the wave is v. So from here we will get k is equal to omega by v only. And here also we know that k is equal to also 2 pi by lambda. We have derived this earlier part of the video of the wave. Okay. So finally we have got the equation k is equal to omega by v, and this is equal to 2 pi by lambda. So we will use to find different type of thing. Now one thing we need to understand, that opposite signs omega and k means it means the v is positive. What do you mean by this? Let us consider let us consider this. There is a wave, and the wave is moving in this direction, in positive x-axis direction. So if wave is moving in this direction, so x is equal to positive. So the equation will be y is equal to a sine omega t minus kx plus phi. So where the sign of this and this both are opposite, the sign is opposite, that is one is negative and another is positive. So finally the velocity will move in positive direction of x-axis. Now if we consider that if the wave is moving in this direction like this, like this, like this, so opposite direction. Okay, so the wave is moving in this direction, in the negative direction of y-axis. So what will be the symbol, or what will be the equation? So y is equal to a sine omega t minus, in place of minus, either we can write kx plus phi, or we can also write like this: a is equal to sine minus omega t minus kx plus phi. So here what we got this understanding is that if the sign of both the in front of both omega as well as k is positive, so we will get the movement of the wave in negative direction. Either we can also say that if the sign is negative, if the sign is negative on both the sides, same sign means it will move in a negative direction. Opposite sign, it means that it will move in a positive direction of the x-axis. So I hope you have understood this thing, right? Now, the second type of wave in form of wave is a secondary stationary wave. What do you mean by stationary wave? The wave will stop. It won't move. See here. Is it moving? It won't. This is not moving. So the but wave is have been continuously moving, but the movement of wave or progression of wave is not there. Why it is not there? See, this wave remains stationary between two boundaries. So we can understand that we are having a two boundaries. So from within a two boundaries, this wave are moving. So the energy is not propagated by this wave, but it is confined in a segment or a loops. So what happens here? So the energy is not propagated by this wave. How propagation will happen? So it will confined between these two structure only, these two fixed point only. So the wave in a string or a wave in a organ pipes are the example of this type of wave. Okay, I hope you have understood the stationary wave. Now let us move forward. So the progressive wave, so it will be the continuous movement of the wave for a long infinite time, but for a stationary wave, it will be confined within two boundaries. So I hope you have understood now. now, now one more thing need to understand. What is the equation for the wave? Here, a transverse wave is represented by the equation 4 sine pi by 6 into sine 3x minus 5t 15t. We need to find what it has amplitude or speed of propagation or wavelength. So first of all, we know that y is equal to a sine omega t plus phi minus kx. Okay, so now compare this equation. So I will change the color of the equation. Hmm. So y is equal to 4 sine pi by 6. So sine pi by 6 means what? Sine pi by 6 means, so it is 30 sine 30. So sine 30 means half. So this is constant. So 4 into 1 by 2 into sine 3x minus 15t. Okay, so this will be y is equal to 2 into sine 3x minus 15t. Okay, now let us see here what is the, we need to compare this equation with this equation. So here we got that phi is equal to 0, phi is equal to 0. So here we don't have a phi value. Okay, it's now okay. Now let us consider what is amplitude. So amplitude here a, so this a is equal to 2, so amplitude is equal to 2, but the option is amplitude is equal to 4. So I hope you have understood that this option is an incorrect one because amplitude is only equal to 2. Now what is the value of omega? So in place of omega we can see that omega t, so this is a 15. Okay, and in place of k we have got k is equal to 3. Now if we talk about the speed of our propagation, so v is equal to what? So let us go and reback and see the equation. So v is equal to, can we write here from this equation, k is equal to omega by v. So from here v is equal to omega by k. So why don't we use this equation, v is equal to omega by k. So v is equal to omega by k, that is 15 by 3, that is equal to 5 meter per second. So I hope you have understood that this speed of propagation is the correct answer. Now let us suppose that if you want to find a wavelength, so how you will find the wavelength? Now let us see wavelength. What is the formula for the wavelength? So from here we can find wavelength is equal to 2 pi by k, or there are many several processes, so why not we use 2 pi by k? So let us see here, wavelength is equal to, wavelength lambda is equal to 2 pi by k. So the value of k is 3, so 2 by 3 pi. But here we are getting 4 pi by 3. So definitely the option B is the incorrect one. So this is wrong. Now let us find out the period for the wave. So period is time period is how much time period. Time period omega is equal to 2 pi by t. So why not we write here t is equal to 2 pi by omega. So 2 pi by omega. So time period is equal to 2 pi by divided by omega has a value of 15. So 2 by 15 pi, but the option is pi by 15 only. So from here we have got this wrong answer. Only C option is the correct one. I hope you have understood the process of how to solve this type of things. Okay. Now let us go for further for a wave equation. So let us again we discuss about the wave equation here. We have seen that y is equal to a sine omega t minus kx. Now one more thing, always remember k is equal to omega by v and this is equal to 2 pi by lambda. Now take omega as a constant. If you take omega as a constant, so what you will get? Y is equal to a sine omega t, it will be common, omega will be common, so this will be k by omega. Now we know that k by omega is what? See here, k by omega is equal to 1 by velocity. So here we can write here k by omega is equal to 1 by velocity. So the finally equation will be like this. So if you take the omega as a constant, so you will get the formula for the equation like this. So I hope you have understood this thing. Okay, now let us consider this a y is equal to a sine omega t minus kx. Now if I will take k as a common, so what we will get? A sine k as a common, so what you will get? See here, vt vt minus x. See, if you take k as a common, so this will be omega by k into t minus x. So here omega by k is what? See here, omega by k is what? Omega by v is equal to omega by k. So here we got the equation like this. So in this way we can arrange the equation in a different way. Arrange the equation in a different way. Arrange the equation in different way. In different way. Okay. So I hope you have understood now. Now let us suppose one more question. Mm, you can solve this type of question in your own way. Okay. Now let us consider wave and a particle velocity. So if this is the wave, so it has some velocity. So as we know that the equation for wave is y is equal to a sine omega t minus kx plus phi. We can also consider this is in the form of a phi constant only for a particular value of x. Why particular value of x? Let us consider if I'm talking about the wave, this type of wave. See here, this is your wave, and I want to know the motion of the wave particle. See everywhere what is happening, particle is moving. Here also particle is moving. Here also particle is moving. So for a particular particle, I want to study the motion of the particle. If you go through deep, and then you will find that each and every particle is doing an SHM. Why so? I am telling, let us consider this is a wave. So for a certain time, certain period of a time, you will observe that the particle here, the particle is moving here ups and down. Here also it is moving maximum, and it is down, it is moving maximum. So the particle is moving for a same time period, particle is moving, but at this end, particle movement is zero. Okay, because and this is known as node. This is known as node. Okay. Now if y is equal to a sine omega t minus kx plus phi, and if I am telling that I want to study the movement of this particle for a particular value of x, so it means that we have known that x is a constant because we have got the value, and I want to study the motion of this particular particle. So if it is k into x is a constant, so finally we can treat as a constant term only. Okay. Now if for a particular value of x, vp is the velocity of the particle, so velocity of the particle can be written as dy by dt. So if we differentiate it, so we will get a into, this is a variable term, so it will come outside, and this is sine differentiation is cos omega t minus kx plus phi. I hope you have understood. Now can we write here, if we do square both the sides, so y square omega square is equal to a square sine square a square uh, y square omega square. Let us do this y square into omega square, y into omega square. Let us multiply it for example, this is the equation, so we can rewrite this equation as y omega is equal to a omega sine omega t minus kx plus phi. So here a omega. So let us suppose square both the side. So we will get y square omega square is equal to a square omega square sine square omega t minus kx plus phi. Now we know that if velocity of the particle, now we know that velocity of the particle whole square, if we will do, so this is the velocity of the particle, vp square is equal to a square omega square cos square omega t minus kx plus phi. Why? Because if you square both the sides, so you will get velocity like this. So since we know that in place of a omega square sine square omega t, what we can write? See, if we add both the equations, so what you will get, omega square omega y square omega square plus bp square, this is equal to a square omega square is a common, so sine square theta plus cos square theta will become 1. So finally we will get velocity of the particle as omega into root under a square minus y square. Okay. So we have finally got the velocity of the particle. Okay, now if we talk about velocity of the particle, that is Vp is equal to omega. Vp is equal to omega root under root under a square minus y square, where a is the amplitude, maximum amplitude, and y is the particular movement. Now if we want to find the acceleration of the particle, so if you want to find acceleration of the particle, can we differentiate dp by dt? So if we differentiate the velocity of the particle with the time, so we will get that ad by dt of a omega into cos omega t minus kx plus phi. Why? Because this is the value of velocity of the particle. Let us check it. So this is the velocity of the particle, that is a omega cos omega t minus kx plus phi. Now if we differentiate it, so we will get a minus a omega square sine omega t minus kx plus phi. So finally, you know that a sine omega t minus kx plus phi is y. So can we write here acceleration of the particle as omega square into y? Now we know that in SHM, in any SHM movement, so the velocity is maximum Vmax at the portion, and acceleration is maximum at the extreme position. So acceleration is at extreme position, it means the value of y is how much? So value of y will be equal to a at extreme position. So hence acceleration of the particle, maximum acceleration of the particle we are getting is y minus omega square a. Now let us consider uh, velocity of the particle when velocity of the particle is maximum. So if any SHM is there, so it has mean point. At mean point, y is equal to 0. So if y equal to 0, the velocity will become maximum. So can we put here y is equal to 0? So if I will put here y is equal to 0, so the velocity of the particle, maximum velocity of the particle is omega a. So I hope you have understood and got many relation. Now let us consider some of those problem can be solved here. A transverse wave is represented by y is equal to a sine omega t minus kx. Y is equal to a sine omega t minus kx. From the value of the wavelength is the wave velocity equal to the maximum particle of the velocity. Maximum particle velocity. So Vmax is equal to what? So Vmax is equal to a omega. Why? What we have written here? Vmax is omega a. So omega a. So here a is the amplitude of the particle, omega is the angular velocity. So the okay. Now we have got the maximum velocity as like this. Now we see here a transverse wave is represented by like this. For what value of the wavelength is the wave velocity equal to the maximum particle of the velocity? What value of the wavelength? For what value of the wavelength is the wave velocity is equal to the maximum velocity? So let us consider, we know that wave velocity v is equal to what? V is equal to, let us go through and revise the same formula. V is equal to omega by k, or V is equal to this can be written right like this. So let us consider V is equal to, can we write here V is equal to omega lambda by 2 pi. So from this equation we have got V is equal to omega lambda by 2 pi. So V is equal to omega lambda by 2 pi. They are asking for what value of lambda, this velocity will become this max. So let us equate this. So we will get omega lambda is equal by 2 pi is equal to a omega. So omega got cancelled. So lambda is equal to 2 pi a. So finally, which is the correct answer? We need to find out. So our answer is 2 pi a. So finally, we have got the answer is 2 pi a. Okay. One more thing is very important. Velocity of the particle is equal to negative velocity of the wave into slope of the wave. That is equal to Vp is equal to minus V omega velocity omega into slope. or we can write this equation. So this equation can be used to solve the problem. Okay, so I will discuss all the thing next in a next part of the video. So thank you for watching my video. I hope you have understood many things. Thank you.